All right, we'll go ahead and get started. So welcome everyone. My name is Lauren with Plano Public Library, and I want to thank you all for joining us today for STEAM skills and coding and circuits. So your microphones have been muted and videos turned off for this program. Please note that if you have any questions, feel free to type those into the chat. We will monitor the chat and bring questions to the presenters' attention. The presenters and chat moderators today will get to as many questions as we can during this program. All relevant links for the program today will be posted into the chat. So today we have the honor of introducing the Society of Women Engineers. SWE motivates women to achieve full potential in careers as engineers and leaders, expand the image of the engineering profession as a positive force in improving the quality of life, and demonstrates the value of diversity. So SWE will present the STEAM Skills 5-week course on coding and circuits. And today you will continue learning about TinkerCAD and Arduino with Neha, Maha, and Nuha. So a few housekeeping reminders that we would like to share with everyone. The first is we want to note that this program is being recorded and will be made available on the Plano Public Library YouTube page for later viewing. Soliciting business or selling items during the library virtual programs is prohibited. And please be considerate of our presenters and one another throughout the program today. Any inappropriate behavior will result in your immediate removal from today's program. So I will now hand it over to our presenters.
Thank you, Lauren, for the introduction. I'll go ahead and share my screen. Okay. Hi, everyone. My name is Maha, and this is week 5 of our Arduino and TinkerCAD workshop. So this is what we'll be covering today. First, we'll do a recap of some of the things that we've talked about in terms of setting up your Arduino account, and then we'll go through binary, Arduino functions, and then the mini project in TinkerCAD. So first, our recap. What is TinkerCAD and Arduino, and how do you make an account? So last week we made an account and we looked at TinkerCAD. But just as a reminder, TinkerCAD is a free and intuitive web-based CAD program that anyone can use. So you can do circuit design and simulation features, and they have a lot of different components. So you can make real-world circuits and simulate them. So making an account. So you'll go to tinkercad.com/join, and then you'll create your own personal account, and then fill in your information to start creating your account. And then if you're over 13, you can add your own email, but if you're under 13, you will need to have a parent's permission to be able to use TinkerCAD. So if you're under 13, you will need account approval. So you'll have to fill out a permission slip, and then you'll be able to have your own account. So what is Arduino? It's an open source electronic prototyping platform that also sells microcontrollers. So in TinkerCAD, what we've been doing is we've been using an Arduino microcontroller to be able to run our circuit and program it the way that for the project that we're working on. So Arduino is a big company, and these microcontrollers are different Arduino products. And Arduino language is a C++ based language. So when we use the microcontrollers, they have their own specific language, and it is a little bit different from C++, but if you know C++, then Arduino language is very easy to pick up on. And then this website, Arduino's website, has a lot of forums and a lot of tutorials to also be able to use this microcontroller in different circuits and different projects. Okay. And now I'll pass it off to Neha to continue with the presentation.
All right, so hi, I'm Neha, and okay, should I share my screen? Okay. All right, thank you, Maha, for the introduction. So before we get into any Arduino or TinkerCAD, first I want to go over a concept called binary, which is used in a lot of computer science and engineering concepts, and it's really something that's going to help you out in the future. So I really think this will be a good foundation for what we're going to do later. So first, we're going to talk about digital information. A computer stores information digitally as binary numbers. So any information on your computer, like numbers, text, graphics and images, video, audio, or even the code that we've been writing in C++, it's all stored as binary numbers. So in some way, all of our information is digitized. It's broken down into pieces and is represented in binary. So the binary system only has 2 digits. We have 0, which is low or off, and we have 1, which is high or on. So you can think of it kind of like a light switch being on or off. A single binary digit, 0 or 1, is called a bit. A single bit can represent 2 possible states, like a light bulb that is either on, which represents 1, or off, which represents 0. And binary is a base 2 number system. So in our daily lives, we use numbers like 15 and 10 and 20, and these are all base 10 numbers. That's called a decimal system. Binary is a base 2 number system. So there are 2 to the n permutations of n bits, which I'll get into later. And it takes 8 bits to make a byte or a character that represents a form of data. So on your computer's memory, if you've ever seen like file storage sizes, you might have seen letters like KB or MB or GB to indicate memory space that a certain file or program takes up. And those letters stand for kilobytes or megabytes or gigabytes, all of which are different amounts of bytes. So one file might need 1 KB of bytes, which is 1,000 bytes, or another might need 1 MB of bytes, which is 1,000,000 bytes. And since each of these bytes is made up of 8 bits, you can imagine that our computers have enormous amounts of bits to store things. A huge number of ones and zeros are behind everything that we're storing. So really here, when we're talking about bits and bytes, we're talking about very tiny units of memory. And to store anything useful on our computer, we need thousands and millions of these little pieces. So back to bit permutations that are introduced before. So I mentioned on the last slide that there are 2 to the n power permutations if we're given n bits. So you can think of a bit as basically just being a digit. A permutation is basically a way that we can arrange digits. So let's say we have red, blue, green. A permutation of that would be blue, green, red, right? It's just a different ordering. That's basically all that we're doing. So let's say that we only have 1 bit of storage, right? We can only store 1 or 0. So mathematically, we can find that by doing 2 to the power of 1 to say 2 items. Let's say we have 2 bits of storage. We would have 2 to the power of 2 or 4 items. For 3 bits, 2 to the power of 3 or 8 items. And 4 bits, 2 to the power of 4 or 16 items. And I'll elaborate on the next slide. So here's a better representation of what bit permutations are. So each additional bit digit doubles the number of possible permutations that we can have. So if we only have 1 bit of storage, we can only store 2 possible items. We can store 1 or we can store 0, because in base 2, there's only 2 possible digits, right? In base 10, we have 10 possible digits, 0, 1, 2, 3, 4, 5, all the way up to 9. But in binary, we only have 0 and 1. So let's say we have 2 bits of storage. We have a little bit more storage. We can store 0, 0, 0, 1, 1, 0, or 1, 1. If we have 3 bits, now we have 3 spaces, and there's 8 possible permutations. And if we have 4 bits, we have 4 possible spaces. So we can store 16 total items. So let's go back a little bit and talk about what is binary. The word binary basically just means 2. The binary number system has 2 symbols, 0 and 1. A bit, which is short for a binary digit, is the smallest piece of data that a computer knows. So it's a single digit which can be either 0 or 1. A word in computer science is a group of any number of bits. And a byte is a group of exactly 8 bits. So going back to what I was talking about with the permutations, you would have 256 or 2 to the power of 8 different combinations if you wrote down all of the possible combinations of ones and zeros that make up a byte. So here, let's say we only have 0, then we only have one option. If we have 1, then we have 2, and it's all just going to be based on powers of 2. Let's say we wanted to convert a binary number to decimal. So let's say I have a number like 101010001 in base 2, and I wanted to convert that to base 10. Base 10 is basically just the numbers that we're used to seeing in our regular lives, like 99 and 67, like just those regular numbers, right? So here's the process that we would use to convert this weird binary number to a number that we're used to. So first, we would place all of the digits in a row like this, right? So 1, 0, 1, 0, 1, 0, 0, 1. Then we would start on the right side, and the place value would be 2 to the power of 0. And then we would just work our way from right to left. 2 to the 1, 2 to the 2, 3, 4, 5, 6, 7. Okay, and then as you can see on the left side, I basically worked out the math. So for any ones that you see here, you would multiply it by the place value. So 1 times 2 to the 7, which is 128, 1 times 2 to the 5, which is 32, 1 times 2 to the 3, which is 8, and 1 times 2 to the 0, which is 1. You would add up all of these numbers to get 169. So basically, this number in binary that we see, 101010001, is 169 in our base 10 number system. And notice that we didn't count any of the zeros. That's because if we multiply 0 by anything, we're just going to get 0. So we can ignore those. So as another practice example, we can try converting this number, 11000011, to decimal. And I worked out the math here. And at the end, we get 99. And just be careful to start with 0. So we would start with 2 to the power of 0, not 2 to the power of 1. Now we're going to talk into some Arduino commands. Let me check if there's any questions. How do you know if it's a 2 to the power of? Not sure if I understand the question. All right, so now we're going to jump into some Arduino commands. So as Maha mentioned before, the program that we're going to be using today to talk about circuits is going to be Arduino. And these are some of the basic commands or functions that are used in Arduino. And we're going to be using these in our mini project. So there's 3 main commands that are used in Arduino. One is digital read, the second is digital write, and the third is bit read. So first, I think it would be good to discuss what a function is. A function you can think about, as in your math classes, as y equals f of x. So x is the input or the argument that we're passing in, f is the name of the function, and y is just this variable that we're assigning the output to. So x is our input and y is our output. And that's going to help us understand these Arduino commands. So the function digital read, you can think of as f, is going to be a function that reads the value from a specified digital pin, which is going to be either high or low. And the syntax is digital read parentheses pin. So similar to f of x, our x or argument or our input is going to be the pin, which is either high or low, and the function f is going to be digital read. And so like I said, our parameters or x, which is going to be our input, or the pin is the Arduino pin number that we want to read. And after we execute this function, we're going to have an output, right? So for every x, there's going to be a y. So we're going to return a value that's going to be either high or low. So in this yellow box here, we can see an example. Val equals digital read in pin. So in pin is the name of the variable that we're inputting. It's going to have a value either high or low, and we're going to input it into digital read. It's going to read that input pin, and then we're going to output it to the variable val, which is going to be an integer. So basically, digital read returns Boolean data, which is either high or low, and it's saved in the integer variable named val in the above syntax. So one important thing to note here is that we're reading the data from this digital pin. So that digital pin, so in order to execute this function, we must have an input, right? We can't just read in nothing. We can't just have a blank space in this parentheses. We have to have an input there. And we'll basically assign that to the variable val. And as a refresher, a Boolean data is basically just something that can only have two states. So true or false, 1 or 0, kind of like binary. Our next function is digital write. And digital write writes a high or low value to a digital pin. It basically sets the LED to the button's value. So this function requires two inputs. So we would write digital write, parentheses, pin, and then value. So our parameters are going to be the pin, which is the Arduino pin number, and our value is going to be either high or low. So we're basically setting the LED to a certain value. So we're making the pins as an output, which will require the digital write function to write or send data to the required device, like LEDs or motors or etc. Our last function is bit read. And this basically just reads the bit of a number. And this also takes in two inputs. So bit read, comma, parentheses, x, n. So x is the number from which we're going to be reading. So it's going to be some sort of binary number like 1100. And n is the bit that we're going to read. So starting at 0 for the least significant rightmost bit. So for example, we'll be reading this bit right here on the rightmost side. And we're going to return the value of the bit that we're reading. So as you can see here, we have a for loop. And what a for loop is going to do is it's going to iterate over this entire binary number, 1100, and it's going to read each thing bit by bit. So 0011 is going to read each bit for each I or each n, I guess, and it's going to print each of those bits one by one so that we can see it on our screen. So we can call the function bit read to extract the value of specific bits from that byte. So once you have the bit value, you can output it to a digital pin or do whatever else you want to do with it. And this can be helpful in certain applications, which we'll discuss in our mini project. All right.
Hi, everyone. So now it comes time for our mini project. So I'll go ahead and share my screen. Today, we're going to be creating a 4-bit LED counter. So let me go ahead and share my screen. Right. And just as a review, we're going to be talking about the LED and the resistor, just because those are two electrical components that we used last week and we're going to use again this week as well. So after kind of discussing the Arduino Uno, reviewing kind of what that microcontroller does and the three main functions or commands that we're going to be using, I want to review resistors and LEDs just really quick. LEDs stand for light emitting diodes, and they turn on when they receive a certain amount of current or power. They're polarized, meaning they have a positive and a negative side. So you'll notice on our LED right here, on that left-hand side, there's the anode, which is the positive side, and then the cathode is the negative side. The positive side must be connected to the power side and connected to power, and the cathode must be connected to the ground side for the LED to work. Just as we did last time, we're going to be connecting that anode to an analog pin within our Arduino to send it power, and then we're going to be grounding that cathode. And we'll also be incorporating a breadboard, which is something we introduced last time. Along with the LED, the ground, power, and the breadboard, we're also going to be using resistors. Resistors are really important because they reduce the amount of current flowing in the circuit. It's important because if too much current flows through an LED, it can burn out. And while TinkerCAD warns us, gives you a little warning if you have a resistor that's too little and too much current is going to the LED. It gives you that little warning. However, in real life, you have to be careful about it because there's no kind of real warning. And so that's why it's really important that whatever electrical components that you have in your circuit, you make sure to do a little bit of research and make sure that, okay, this resistor will make sure that I get just the right amount of current to where it's going to flow and my circuit's going to work, but also just below the limit to where my electrical component won't burn out. So another important thing about the resistor, unlike the LED, is that the resistor is polarized. So the way that, it is not polarized, meaning that whichever way you orient it, it doesn't really matter. Like the LED, it also has two legs, but there's not an anode and a cathode like it is for the LED. So whenever you're making those connections on your breadboard and to your Arduino, it doesn't really matter which way the resistor is. There are various charts that you can find online that teach you how to read the values for each of the resistors. You'll notice that there are 4 bands. Band A is the first digit, band B is the second digit, band C is the multiplier, and band D is the tolerance. So whatever value that we have for our resistor, that value you can read using a chart online, or if you just know the various color codes for that respective resistance amount. However, in TinkerCAD, when we're working with this virtually, we have the option of manually entering the number of ohms that we want our resistor to be in. So we don't really have to worry about color codes because TinkerCAD takes care of that for us. All right, so whenever we're doing today's project, we're going to be once again incorporating multiple LEDs in a breadboard with Arduino and TinkerCAD. There are 5 main steps, and I wanted to include this slide. That way, when you guys refer back to it, you guys can just have a quick read over these 5 main steps. But the next slide will feature a video that we'll watch that is an instructable on how to make these connections with all these LEDs. One important thing that you should always start is connecting the Arduino's 5-volt pin with the red positive rail of the breadboard, which is something we talked about last time. Also, we'll need to make sure that we ground the Arduino pin with the negative rail on the breadboard. You have to position your LEDs, that way the 2 legs go in 2 different rows of the breadboard. So once in TinkerCAD, when you're putting these on your breadboard, it automatically kind of positions them to make sure that they're in 2 separate rows. But whenever you're creating these circuits with real components at home, make sure that your 2 legs are never in the same row on that breadboard, because each row, you can think of it like a row of connections, right? So you have to make sure those 2 pins have separate connections, so they need to be in 2 separate rows. You need to attach wires to any of the holes in the same row to make an electrical connection. So for example, this is a little bit zoomed out, and of course we'll zoom in once we're actually creating and doing the demo, but you'll notice that there's a bunch of holes within that same row. This resistor, you'll notice that there's an empty hole between that and the LED pin, and that's okay because this entire row is one connection. So you can connect it to any of the holes as long as it's in that same row that you're making for whatever connection that you're trying to make. You want to connect your LED to a resistor. Again, make sure the resistor is to the anode because the cathode has to be grounded. And we can add each, however many LEDs that we want, we just have to make sure that we ground each of them, we add them to an analog pin, and that we make sure to add a corresponding resistor. And then within TinkerCAD, you can customize the wire color. So for example, for this demo, they had a red wire going to the red LED, a yellow wire going to the yellow LED, and a green wire going to the green LED. So that's something that you can also play around with, just because once you have a breadboard with a lot of connections and a lot of stuff, color coding it makes it really easy to troubleshoot, because you can kind of see really clearly what's going where and making sure that it's in the right spot. All right, so let's go ahead and watch the video instructions for how to actually create that breadboard with all those connections. Let me go ahead and unshare my screen and reshare it just to ensure that I am sharing sound. Let me go ahead and open up that video. Go ahead and share my screen, share sound. All right, okay.
Let's learn how to control multiple LEDs using Arduino's digital outputs and a breadboard. We'll connect some LEDs to the Arduino Uno and compose a simple program to light them up in a pattern. Take a look at the work plane, where I'll add a breadboard from the components panel. The rows of a solderless breadboard are connected inside, allowing you to connect components by plugging them into the same row as each other. The special long rails along the edges are for easy access to power and ground. It's a best practice to always connect 5 volts and ground to these long rails as a starting point for any Arduino circuit. Try it for yourself in TinkerCAD circuits. Double-click along a wire to create bends you can use to tidy up your circuit. To change your wire colors, select the color in the inspector or use the number keys on your keyboard to quickly switch between colors. Wire connections to 5 volts are typically red, and those connected to ground are typically black. Let's recreate the blink circuit using the breadboard. Add an LED to the breadboard so its legs go into 2 different rows. If your breadboard's up and down, you can use the rotate tool. Attach wires to any of the holes in the same row to make an electrical connection. Just like before, we want to connect the LED and resistor in series to pin 13 and ground. This breadboard circuit is electrically identical to this free-wired circuit. You can build either way in the editor, but if you're also building a circuit with physical components, the breadboard will help keep your virtual circuit looking the same. Let's add a few more LEDs to this circuit along with their companion resistors. For each, connect one end to ground, in this case through the resistor, and the other end to a different digital output pin on the Arduino board.
All right, and so that video kind of goes on and demos how to create the blink schematic that we made last week with the breadboard. However, we're going to be creating something different, so we are going to be just keeping it at that. And now that we have a good idea for how we are going to be creating the device, we're going to go ahead and go to the next slide and discuss how we're going to be making the 4-bit LED counter. All right, okay. So there are a couple of steps in making sure that we program our Arduino. The first step is to make sure that we assign variables for each LED pin along with the variable for the LED value, 1 or 0 for high and low. We're going to establish a counter, which is going to be the 4-bit number that we depict with our LEDs. And we're going to have another set of variables int W pin, W, X pin, Y pin, and Z pin. And those are going to be our values for the analog pins that we're connecting our LEDs to within our Arduino. For example, last week, we just used the number 13 whenever we were writing a digital write to make it turn on and off. This time in our code, we're going to be replacing that number with a variable that represents that number, which that pin is going to go to. Int W value, X value, Y value, and Z value are the values for X, Y, and Z. X, Y, and Z, when I'm referring to those variables, I'm talking about the individual bits that we're going to have in our LED sequence. So we're representing a 4-bit binary number. So we're going to have 4 different variables. W is going to be the leftmost bit. X is going to be the next one over, Y, and then Z is going to be our rightmost bit in our binary sequence of a 4-bit number. And int counter is going to be the number that we're going to use for our counter variable, meaning it's going to be the counter that goes from 0 to 1 to 2 all the way to 15, which would be the highest number that we're going to represent in our binary sequence. So let's go ahead and tinker a 4-bit LED counter. If you haven't already, open a tab, log into your TinkerCAD account, go to circuits, create a new circuit, and rename your project as a 4-bit LED counter. Of course, I'm going to be sharing my screen in just a bit, opening up the TinkerCAD, and we're going to be working through this step by step. But for now, if you have last week's project already made and saved, you can rename that to Blink if you want. But let me go ahead and stop sharing my screen for just a minute. And I am going to be opening up TinkerCAD. And we're going to start by creating our 4-bit LED counter. All right, give me 1 second. All right, move this over here. And let me go ahead and share my screen. All right, let's go ahead and share this one. Okay. So when you log into TinkerCAD, you enter your username, your password, you're going to see something that looks a little like this. As I kind of mentioned in the previous slide, we're going to hit circuits, and then we're going to create a new circuit. This is going to be something that we're going to do completely from scratch. So we're going to have kind of an empty workspace, which TinkerCAD kind of already automatically gives you. Here is how you can rename your project. So it just gives you a random name that TinkerCAD generates whenever you create a new project. We'll go ahead and rename that as 4-bit LED counter. All right. And what we're basically going to do now is we will first add our components. So let's go ahead and add that right here. We're going to take just a search bar right here and write Arduino, and it will generate that for you. You'll click it and it'll automatically bring it to your workspace, and you'll hit just 1 click to have it actually be on your breadboard or your workspace, excuse me. I'm going to go ahead and zoom out so we have room for our breadboard, which I'm going to put up here. Now, when you search breadboard on TinkerCAD, there's going to be multiple sizes of breadboards. So for example, there's a breadboard small, a breadboard mini, and a breadboard that is actually the size of a real breadboard that you'll find. And it's just the breadboard small, but it's just a little bit longer. For our purposes, since we're not working with a whole bunch of electrical components, just 4 LEDs, 4 resistors, and a little bit of wires, that breadboard small will work just fine. So go ahead and click that and bring that over to your workspace right above your Arduino. Now, remember the first step that we talked about in our PowerPoint and then also in that video instructable is making sure that you power the breadboard. So we're sending a bunch of electrical currents and voltage to this breadboard because that's where we're making our connections, right? That's where we're having our LEDs and resistors. So we have to make sure that we actually give it power and give it some sort of voltage. We'll take this 5-volt pin that's right here, and I'm just going to make a connection from there all the way to my positive LED, excuse me, my positive rail on my breadboard. So you can hit that, and if you double click, it's going to curve your wire. So that's something that I like to do just to make my connections a little more neat. All right, we have that there. Okay, and I like to make this red just so that I know that, okay, this is going to the power, is going to my positive rail. Going forth, we're going to go ahead and ground our breadboard to our Arduino. You'll notice there's a couple of ground pins on our Arduino. There's one up here and there's 2 down here with the 2 voltages, right? I'm going to go ahead and just connect it to the ground pin that is right next to my 5-volt, which is where I set my positive rail on my breadboard too. As this is ground, I'm going to go ahead and change the color to black, just to match the negative rail on my breadboard. All right, now comes the fun part. Let's go ahead and add our LEDs. We'll go ahead and take one, and you can put it anywhere on the breadboard. As I made connections to this positive and negative rail, you have to make sure that whatever electrical components that you put in are going to be on this bottom half. If you're going to make some connections to your top half, you're going to have to connect your positive, the 2 positive rails and the 2 negative rails. That is if you have your LEDs up here. But since we're only going to be working down here, I don't need to connect the two rails, if that makes sense. We'll go ahead and add our LEDs. I'm going to just put one there, take another LED. I like to have just two holes separating them, but that's just, again, personal preference. We'll add our third LED. And again, our LEDs in this case represent our bit in our binary sequence, right? So when you have a binary number that's 4-bit, you have a bunch of ones and zeros, and there's 4 of them, right? So the way our program and what our project is going to be doing is it is essentially going to be reflecting a counter that counts up in binary, and wherever in that sequence there's a 1, there's going to be the LED of that respective bit will turn on, right? So for example, if all the LEDs are off right now, right? So for example, this would represent 0. If we want to represent 1, only this LED would be on. If we want to represent 2, only this LED would be on. And it's going to do that and count up all the way up to 15, which is the highest number that we can have for a 4-bit binary sequence. All right, so let's go ahead and make our connections. I am going to go ahead and make my connections to the Arduino read pin first. So I'm going to connect this first one to pin number 2. And I'm going to go ahead and change these wires to orange, just so that I know that, okay, my orange wires are the ones that are going from my LED to my Arduino. I'm going to make this, and again, when we're making connections, to the Arduino analog pins that we're reading and writing to, you have to make sure that you're connecting the anode, because the cathode, remember, is the negative, which means that it needs to go to ground. We'll go ahead and continue making our connections. This one is going to go to 5. This one is going to go to 8. And this one is going to go all the way to 11. Let's make sure that we got, sometimes it adds a bend when you don't want it in the wire. So now we have all our connections to the pins. The final part in making our electrical components or our electrical circuit is to make sure that we add the resistors and ground them. So I'm going to go ahead and add a resistor, and I will add it right here. And in this case, the resistor value that we're going to be using, it's going to be a we'll go ahead and do a 220 ohm, just like how we did last time. And again, what a resistor does is it restricts or controls the amount of flow of current that's going to that LED, right? So in some cases, if your resistance is too high, it will blow out your LED, but also if it's too high, you won't actually see the LED glow. It's going to be sending current to it, but it's going to be such a high resistance that you actually won't be able to see it glow. And so you can adjust your resistance value to make sure that you get a glow bright enough. But right now we'll go ahead and do a 220 ohm. I'm going to go ahead and copy and paste, just Control C, Control V, and add my final resistor. All right, let's make sure. So you got to make sure, sometimes it blocks it, but you have to make sure that that goes in the right place and in the right row. I'm going to go ahead and move them up just a little bit, just so that we have room to connect the other opposite terminals of the resistors to my negative rail, which will be my ground. We'll go ahead and go 1 straight all the way down. Again, since we're grounding it, personal preference, I just like to make that black. That way I know that those wires are going to ground. We'll go ahead and continue doing that all the way through. And now we have our circuit all set up and ready to code. One thing that I'm going to add, TinkerCAD has a annotation feature. So what I'm going to do is I'm going to write an annotation for each of my bits, right? So this is my W bit. This is my X bit. All right. And that's just by clicking the speech bubble here up at the top. All right, and we'll go ahead and write our WX. Here it's going to be our Y. And then finally, we're going to go ahead and do our X. All right, or excuse me, our Z. All right, I'll go ahead and just move that down. And now we have our annotations. This, of course, doesn't do anything electrically. This is just using the software, using TinkerCAD, and just making sure that whenever we run the code, we know what LED represent what bit. It's just for personal use. All right, now let's go ahead and write our code. So this time, I think that since we're going to be having a for loop and our code is going to be a little more nuanced and dense, I think that we should go ahead and go straight to the text. And we're going to go ahead and write our code for this. Before before our void setup, we're going to go ahead and declare those variables that I mentioned earlier, right? So we had the int w pin, y pin. Let me go ahead and write in all caps. Y pin, x underscore pin, and z underscore pin. And so these variables are for my X, Y, and Z pins, right? So I'm just gonna go ahead and maybe like pin values. All right, X, W, X, Y, comma, Z, pins. We'll go ahead and then write a int W underscore value. This is basically representing whether it's going to be a 1 or a 0, right? In our sequence, if that bit needs to be a 0, if that needs to be a 1. Same way it goes is we'll go ahead and create a Y value for each of our pins, WX, or before Y, we need to make sure we have our X value, Y value, and Z value. And these are going to be our W, X, Y, Z values, 1 or 0. This orange text right here, this slash is are just comments, right? So just like how we code in C++, I like to make sure that we incorporate some sort of comments. That way, when we look back at this code, we'll know what it's talking about. And then finally, we're going to have one variable called int counter, and that's going to be my counter variable, which goes from 0 all the way to 15 and is represented by the LEDs. Okay. All right, so now we have our variables that we're going to be using in our code. Now we have to make sure that we use a setup, right? So I'm going to go ahead and we're still going to be using pin mode, but once again, we're going to be using W pin to represent that numerical value on our Arduino, which that LED is connected to. Our W LED is connected to pin 11, right? So we're going to set that to 11. Our X underscore pin is equal to, so our X is going to 8, right? And then let me go ahead and move this over so we can see the rest. WXY underscore pin is equal to 5. Make sure to include your semicolons and make sure that you are consistent with your capitalizations and make sure there's no typos because otherwise your code will give you some errors. And then our Z bit goes to the second pin number 2 on our Arduino. All right, we'll go ahead and erase that because we're going to be writing pin mode, but it's going to be a little bit different. So now what we'll do is we'll write pin mode and we'll have it be W underscore pin is an output.
Hey, Nuha. We're getting a few requests to slow down.
Okay.
Yeah.
All right. Should we, like from the breadboard connections point or from the code writing point?
Just for the code. So maybe if you could walk through it a little bit from where you are now and then continue, that would be good, I think.
Okay, all right, so I'm going to start up at the very top. As I kind of mentioned before, our W pin, Y pin, X pin, and Z pin, we're declaring those as an integer value that we're going to tell the code, the Arduino, that, hey, my W pin is 11. And that means that this LED is connected to that pin number 11 on our Arduino. Our X is connected to pin 8. So we declare X pin is equal to 8. Our Y pin would be connected to 5. So we have that equal to 5. And our Z pin is equal to 2. These variables, we're using variables just so that we can kind of stay consistent and keep track of which pin goes with what bit, right? If it's the W bit, if it's the X bit, if it's the Y bit, or if it's the Z bit in our 4-bit LED sequence. The int W value or X value, Y value, Z value, of course, we have to set it for each 4 of our LEDs, right? You have to make sure you have your W, your X, your Y, and your Z. This is going to represent the values, whether that bit is going to be 0 or whether that's going to be 1, right? So in our 4-bit LED sequence, we have 4 bits, each of them are either 1 or 0, right? Depending on the decimal number that we are trying to represent in that sequence. If in that sequence, that 1 bit, for example, W, is meant to be a 1, right? For example, if we're trying to represent 15, then W, X, Y, and Z would all be 1, 1, 1, 1. Those values right here that I declared, we're going to assign that to be 1, right? But this variable just represents whether it's going to be a 0 or a 1. It represents the value of that bit in our sequence. Our int counter is the number that we are counting up. So it starts from 0 and it goes all the way to 15. And it is the number that we're essentially counting up, and that is represented in our LED sequence, right? So for example, if counter is 0, then all of my LEDs are going to be off. It's going to be 0, 0, 0, 0, right? Because that's how we represent the decimal value 0 as a binary. If my counter, right, once counter is 0, it's going to go to 1. And therefore, our now binary sequence would be 0, 0, 0, 1. So only Z LED would be on, right? So counter is that actual decimal value that we are printing or displaying with our LEDs. In our void setup, this is the part of
Sorry to interrupt. It looks like on the right side of the screen, the 1s or 0s are just a little cut off. Would you mind painting your screen over just slightly? Thank you so much.
So as I kind of mentioned, these yellow code or written part past the double slashes is just a comment, right? So when you write C++, you represent a comment, and that doesn't actually affect your code. It doesn't help run it. It's just for your sake, just so that when you're looking back at it, you know what everything means. So here I just kind of explained what each of those variables are. And in our void setup, this is where we're going to be using our pin mode function to make sure that each of these LEDs is an output, right? So when you use the pin mode function in the Arduino, or the pin mode command would be a better word in the Arduino language, you either assign it and make it an output or an input, right? For example, if you have something like a button and you're pushing on it, you have to make sure to tell the Arduino that, hey, this is an input. So you have to make sure that you read it, right? In our case, we're outputting something to those LEDs. So we're going to use the pin mode function to make sure that W pin, which we told is 11, right? We're going to make sure that that is going to be the output. And that is, we're making sure that the Arduino knows that, okay, I'm going to be working with this LED, turning it on, turning it off. So I need to make sure that it's set up as an output. We're going to write this same line of code, this pin mode, W pin output, for the 3 remaining LEDs, because we have to make sure that we also declare those as outputs. Otherwise, nothing is going to be sent to those LEDs. You have to explicitly use the pin mode function to declare whatever pin, whatever LED, whatever pin, whatever LED it's going to. You have to make sure that you declare it as an output. So we'll go ahead and continue. We'll write pin mode, and then we'll have X underscore pin, and that's going to be an output. We're going to do that for our Y. Y pin. And of course, these Y pin variables are just the variables that we are using to refer to the pins on the Arduino that the LEDs are connected to. Right, and this is just the same line of code. The only thing that we are changing is which pin we're referring to, right? We have to make sure we have 4 separate lines that talk about, hey, at each of these LEDs, I want you to make sure that you have these as an output. And we'll go ahead and also create a line of code that is serial.begin 9600. Let me see if I can scoot this over. Oh, hold on. Okay. And again, make sure that whatever code that you're writing, this is in your void setup and not in your void loop. The void loop is where we're actually telling and writing code for when the LED is going to be on and when it's going to be off. So we've done all that we need to set up each of our electrical components, right? We told it that, hey, our W, X, Y, and Z pin are these numbers, and you have to make sure that you read those as an output. Now we can actually begin our void loop and create the code that actually uses the counter and make sure the counter goes from 0 all the way to 15 and then displays that decimal value as a binary sequence on our LED, on our 4 LEDs. So again, this is in our void loop section. So TinkerCAD has this kind of pre-existing code that we don't really need. It's kind of built in the second you add an LED to a breadboard and connect it. We don't need it, so you can go ahead and delete it. Before I move on and write the void loop code, which is where it's going to be a little bit more complex, because that's where we're actually counting up and then displaying that to the LED, I do want to pause and make sure that everybody is all good for the void setup section and the int section, right? And these are just variables that we're working with. This is the pin value. This is either if it's a 1 or a 0, if that bit is a 1 or a 0. And the counter is the number that we're actually going to be displaying.
Nuha, can you speak just a little slower?
Okay. All right, I'll give it a minute just for some added questions, if there are any, before we move on to the void loop section. Once again, what we've worked with so far is the void setup section. This is the framework for the Arduino to know what pins we are using, right? We're using 11, 8, 5, and 2. So we have to make sure that we tell the Arduino that these are the 4 pins we're working with. And then we have to use that pin mode command built into the Arduino language. And we have to make sure that we tell the Arduino that, hey, each of those pins, I want those to be an output. That's all you need for the void setup. I have this additional line, serial.begin 9600, because this is the command that you use when you want to print something out in your serial monitor. If we get time for that, I do want to kind of introduce how you would write code to display the different numbers and the different bit values. But this is something that we can add later on. I'm just putting this in case we do get time to actually write the code to print out the numbers and the sequences that our LEDs are showing.
I do think that the screen has moved over just a little bit again, so we're kind of getting cut off on the right.
And again, as I mentioned, any line of code that follows the double slash and it is orange, that is a comment. So you're just going to use comments to kind of explain your code. It doesn't actually interfere with what the code is writing and what it's going to be executing. But we write those in just so that when we refer back to our codes, we know exactly what every line means, just in case it's been a while and you want to jog your memory.
And it looks like we do have a question. Someone is asking, what is 9600?
So this is a built-in command within Arduino that you use whenever you want to print something to your serial monitor, right? Basically, when you want to output or print something within the serial monitor, you're going to use this. I have this in right now, but we might not get to actually printing out and having an output, but this is what that line of code, it's a built-in function similar to how you have pin mode. There's just a serial.begin 96000, which is just a generic command that you use when you want to print something to your serial monitor. And this number is what we call the baud rate of the connection. And that is essentially how fast we're sending data to the Arduino to then print in the serial monitor. In all my past projects and in whatever projects that you might be working with, 9600 is a good speed to have whenever you are actually creating the rate to send to the Arduino to then output to your serial monitor. All right, if we don't have any more questions, actually, I think I'll give it like 1 minute or more just so that everybody is caught up and has these lines of code all done and set. Make sure that when you're having your pin mode and your serial begin, and these lines of code, which are the numbers that the connections are in, make sure that you have that all in your void setup and not your void loop. And double check that you have your curly braces because otherwise you need those for your C++ code, which Arduino is based off of.
Just wanted to break in that if anyone needs to leave, they absolutely can. This webinar is being recorded and you will receive a link to the webinar at a later time.
And it looks like we did get a request to see if we can place the code in the chat. I don't know if that's possible.
I can send that in right now. So I'm not sure if I can send it in the chat. Don't know.
I don't think you'll be able to copy and paste out of the chat for everyone. If people were thinking of grabbing it from the chat, I don't think it will work that way.
Okay, thank you for catching that.
If it helps, I can send the link to the slides right now.
So the slides don't have the code. It just has like bits and pieces of it. You can send the link, but if they're looking to like copy and paste the code, that's not on the slides just yet. We can send that in after the webinar has concluded, just like in a document that can go along with the PowerPoint slides that we sent out, if that seems like that's something that would be better.
That seems like a good plan.
Okay, awesome. Yeah, so once the webinar has concluded, we're going to be sending a link to all of you to the PowerPoint that we showed today, along with a document that has the code that we're writing. So in case that there's some missing pieces, then you can refer to that PowerPoint and then also a document with all this text and all the code. We'll go ahead and move on to the...
Nuha, Sorry, someone said they can copy and paste from the chat. So if it's easy for you to pop it in there, people can grab it. They can try and grab it.
So on my end, as far as like the bars of like Zoom, it just has a Q&A session. I'm not sure why it doesn't have that chat feature on my end. Let me see if there is. Okay. Actually, I think I was able to pull it up. Give me 1 second and I will go ahead and send this first part of the code into the chat to all. Yes. So we have it to all panelists. Let me make sure that it's all panelists and attendees. I'll go ahead and write that in. So you all should have gotten that. Panelists and attendees. I just copy and pasted that into the chat. Now I understand that you can do it in the Q&A session, but I sent it in the chat.
Thank you. Yes, we can see it. Thank you.
Awesome.
And I do have a question in regards to the coding. Someone has asked, does the coding in the void loop vary depending on what the chip is being made for?
Kind of. The void loop is essentially the code that you want to be repeated and that you want the microcontroller, the Arduino, to loop again and again and again, right? So depending on the different gadgets and the purposes that you want that your Arduino to do, right? The actual code in the void loop would be different. But whenever you're creating something with Arduino, you kind of have to think about how can I make this or iterate this to be some sort of loop that repeats again and again to do the function that the gadget is supposed to do. So for different projects, the code in the void loop is going to be different because it depends on what you're trying to do with your Arduino. But the general idea is that the code that you write will be looped again and again until you basically pull the plug on that Arduino. Otherwise, that Arduino is going to keep talking and keep doing whatever you tell it to do in the loop. All right, so we'll go ahead and begin our void loop. We've done the setup. We've given the Arduino all the variables, all the pins that it needs to do the work. Now we're going to tell it what work to do. We're going to start with a for loop, which is something that you guys are familiar with because it's something that we use in C++. So we're going to have kind of the same idea where we're going to be incrementing the counter. So we are going to have for counter, and again, counter is the number that the LED is going to show. It's going to start from 0 and go all the way to 15. So we'll first initialize it to be 0, and then we'll have it go until it equals 15. And then make sure that these are actually semicolons and not commas. And then counter plus plus. We'll make sure that we have our curly braces. And I'll go ahead and write a comment for code. And I'll add my second curly brace. So again, the for loop that we have in our Arduino is basically the for loop that we have in our in C++. It's the same exact idea where we have something that we are initializing. This is essentially the start value. This would be your end value. And this is where you're telling the counter to increment or go up by 1. So it's going to go from 0 to 1, then to 2, then to 3, then to 4, then to 5, all the way to 15. And this part of the code is going to tell you, basically, this is our ending point. We're going to go until that number, that counter, is less than or equal to 15, right? And we'll go ahead and write our code. This is where we're going to be using our bit read function. So within that for loop, I'll go ahead and scroll down just a little bit. we're going to have a 4 lines of code that basically assign bit values from the counter. So the counter is a decimal number, right? It's either going to be 0, 1, 2, or 5, all the way up to 15. It's going to be a base tens number. We have to use the bit read function to essentially read the various bits within that decimal value. So we'll have the Y value is equal to bit read. Remember, Y value was something that we set up all the way. We set that up right here, that int W value, that's essentially saying whether it's 1 or 0, right? In our sequence, because our binary sequence has either ones or zeros, so that value is going to be what determines if that LED is on or off. If that bit value is 1, then that means that LED is going to be on. If the bit value is 0, we're going to tell the LED to stay off. But for now, we have to make sure that we assign an actual value, a 1 or a 0, to that LED, and that's where we use the bit read function. So you'll remember that there is a certain syntax with the bit read function. You essentially have the X, the number that you want to do, and then the N is the certain bit that you want to read, right, in that sequence. For example, this would be the 0 bit, this would be 1, this would be 2, this would be 3. Think about it like your index value, right? So for example, that Y value, we're going to replace X with the actual number that we're trying to read, that we're trying to display. In this case, it's counter. So Y value is going to be counter, but specifically at the 0, 1, 2, at the 3rd bit. And we'll continue writing this code. Right, X underscore value is equal to bit read counter 2, right? Because our X value is going to be, this is the 0 bit, this is the 1st bit, and this is the 2nd bit. Similarly, our Y underscore value is going to be bit read, we're going to read counter, and then this is going to be, which bit are we reading? We're going to be reading the 0, the 1st bit, right? So this is where our annotations come in handy, because we have already written out, hey, this LED is W, this LED is X, this LED is Y, this LED is Z, right? So now all we need to do is assign values based off of whatever the bit read function reads for counter at that specific bit that we specified. Go ahead and do the same thing for Z underscore value. Z underscore value. And we're going to use bit read for counter and then for 0. Now don't forget your semicolons. I know in Python you don't need to have your semicolons, but in C++ you definitely do. So make sure you don't miss that like I just almost missed. All right. Right, so let's say that we want to represent the number 0, right? Let's say 0 is our counter because that's where it starts off. The binary code for 0 is just going to be 0, 0, 0, 0, right? So W value, it's going to be whether it's 0 or 1. In this case, it's going to be 0, right? Because the bit read function is going to read 0 at the 3rd bit, and the 3rd bit is 0 for the 0 decimal number, right? Maybe a better example would be, let's say we want to do the number 8. 8 would be 1, 0, 0, 0 in binary, right? So the Y value would be counter, so 8 at the 3rd bit. And the 3rd bit, when you have 8 as a binary number, would be 1, right? Because it would be 1, 0, 0, 0. The reason why we're using variables and not necessarily specifying whether it's 1 or 0, it's because 1 and 0 depends on whatever decimal value you're trying to show, right? So this pin might be 1 in some decimal numbers, but it won't be 1 in other decimal numbers. And that's why we're using a variable to represent that.
Nuha, someone asked, what is the number after the counter?
Number after the counter. Okay, so this number right here, it's the bit that we're trying to read, right? So when you have the bit read command in Arduino, and Neha touched on this, but there's kind of a syntax that you use whenever you are using built-in commands. So the bit read function has two parameters. It has X, which is the number that's going to be read, and N, which is the bit to read, right? Which starts at 0 for the least significant rightmost bit. So this is which specific bit we're trying to read. In the case of W, right, if we go all the way here, this is going to be our third bit, right? Because whenever you're doing something in binary, it goes from 0 all the way to however many bits you have. But it starts from 0, and 0 is your rightmost. So normally, right, when we're doing something in English, it's just normally would be 0, 1, 2, 3, but 0 is the bit that is the rightmost whenever you are using binary, right? So that's why Z value would be the 0 bit right here. Y value would be the 1 bit, and then X would be the second bit, and 3 would represent the third bit, which we know to be W. So it's the second parameter that you use to specify which bit you want to read.
Thanks, Nuha.
Of course. All right. So now comes the part where we're actually going to be passing. And of course, just as I did before, once I write the complete void loop section of the code, I'm going to send it in the chat just as I did with the void loop, okay? So we'll go ahead and write the code that passes the assigned bit values, right? Which are either 1 or 0, 1 or 0, depending on what number we're trying to show, to the LEDs to display. And remember, ones and zeros, 1 would be the LED would be on, and 0, the LED would be off. So in this case, we're going to use the digital write function. The digital write function is what we use to actually tell an LED to do something, right? So last time we had a code that looked like this, right? We had something that looked like this. This is how we use the digital write function last time, and it's something that you probably are more familiar with. This time it's going to be a little bit different because you'll remember that 13, we specified that as a variable, right? So we'll replace that number with the variable, and instead of high and low, we are going to use the bit values from the counter, right, that we read. So for example, when we're setting it up for the leftmost bit, the third bit on our left, we're going to write that as W pin. And remember, W pin, we've already set that up in our void setup. That's 11. You could type in 11, but for me, I feel as if working with variables is a lot easier just because it makes troubleshooting a little bit easier. We'll digital write to that W pin our W value. And our W value is the number that we read at that third bit for our counter, right? So this is either 1 or 0. So it is basically telling, hey, at pin W, at pin 11, make sure that you have either a 1 or a 0, right? If it's a 1, that's going to send a high and make the LEDs on. And if it's going to be a 0, right? If the bit read function is going to return a 0 in the counter at the third bit, then it's going to write that 0, making sure that that LED stays off. Again, we write this for every LED that we have, right? So after the X pin, what do we want set to the X pin, the X LED? We want the X value, right? The return of the bit read function at the second bit. Similarly, we're going to need to write digital write for Y pin, Y underscore value. Don't forget your semicolons and for your parentheses. And then X underscore Z underscore pin, and then Z underscore value. Right. And now I'm going to have a delay function, right? And this delay function is going to be the delay between each number, right? So when counter goes from 0 to 1 and the LEDs have to turn on and off, that time period, that delay is what I'm setting with my delay function. I'm just going to make it 1000. Remember, in Arduino, that number that you enter is the amount of milliseconds. So 1000 milliseconds is just going to be 1 second. So the LEDs will count up at a delay of 1 second between 0, 1, 2, 3, 4, 5. If that makes sense. Let me go ahead and
really quick, I hate to interrupt, but I just wanted to let everyone know, I know we're getting a few questions about how much longer the session might go. And we just want to let everyone know if you do need to leave, you can leave whenever you need to. You will be emailed slides and a link to the recorded webinar in a few days. Thank you.
Perfect. Okay. And I think the last thing, we'll go ahead and we'll save that in case at the very end, and I'll include that in the document that I will send to be sent out to all of you for the code file with all the code that we're writing. I just want to double check. I think I need to send this point, my void loop. I'll go ahead and send that in the chat. And all right, okay. All right. So that is your line, that's your code for the void loop section, excuse me. I'll give it 1 or 2 minutes, and then we'll go ahead and run our code and see if there's any adjustments that we need to make or if that it works. Double check. Make sure you have all your parentheses, your semicolons. Make sure your wires are correct, right? You got to make sure that you have a wire going from the 5 volt to the positive rail and ground going to the negative rail. Make sure you connect your series resistors and LED to ground, also known as that negative rail, and make sure you connect that anode to those pins that we established up here, right? These numbers represent what pin each LED is going to.
Nuha, someone asked if that was the code that you just posted, if that was for the loop, the void loop.
Yes, yes, that entire code goes into your void loop section. So I copied and pasted the entire void loop section, so make sure if you're cutting and pasting it that you replace the void loop that's already built in, because you don't want to have 2 void loops, if that makes sense. But this entire for loop and the delay, that all goes within that void loop section. So if in your text, in your code, if you already have that void loop, curly braces and everything, that TinkerCAD generates automatically, and then make sure that the only thing that you're cutting and pasting is the for loop and the delay. And make sure to include that last curly brace. All right. All right, and whenever we finished coding and programming our Arduino, once we've told it, hey, here's the pins that we're working with. These are the outputs that we're working with. All right, hey, this is the work that you need to do. This is what you need to be digital writing, digital reading. Once you've told that and you actually want to see if your code works, you'll go ahead and click the Start Simulation button. So I'll give it just a couple more minutes in case there's any more questions. And yes.
Nuha, it looks like some people have experienced errors. Someone had an error with their Z value.
All right. Let me go ahead and run my code, see if it works. Okay, so hold on. Expected. Make sure that we have our inner void loop. We have that. So there's something right here. Make sure you have a semicolon right after that delay function. That's probably what's messing that up since I cut and pasted it. Okay. So now your code should work and your LEDs will light up the binary sequence. So for that error about the Z value, make sure that you have initialized this line of code to be the values for each respective bit if it's going to be 0 and 1, and make sure that whenever you're writing in that variable you have no extra spaces, and to make sure that that Z bit is the one at the 0 place, or the 0 bit.
Nuha, may people be experiencing errors if they are just directly copying and pasting when they need to type it in?
So one error that you might be getting if you directly copy and paste the code that I set was there was a semicolon missing after the delay function. So that delay line that you have, make sure that there's that semicolon in there. Another thing that will probably be giving you the error if you are cutting and pasting the code is if you cut and pasted void loop twice. So in the code that I sent in the chat, it was essentially this entire void loop section. Make sure if you are cutting and pasting that you don't cut and paste the void loop part, that you're only cutting and pasting that for loop and that delay function. And that makes sense. So if you already have the void loop section in your code, make sure that within that curly braces, you don't have another void loop. You should only have 4 curly braces, right? You should have one right here, right after void loop, and one in line with that. And then you should have 2 in line for the for loop. So if you have a curly brace that's not there, an extra curly brace, then that is something that might be determining. Make sure you have your void set up right here, those 2 curly braces. Let me see. So you could be getting a pin mode out error, that W pin and output. If you didn't tell it what numbers to use. So you have to first write this line of code that tells, just as you do in C++, whenever you're declaring int variables, to have that int W pin, Y pin, X pin, Z pin, that comes before your void setup. And then you'll take it, and within your void setup, you'll actually assign numerical values to those variables that we declared up here. So if it's giving you an error on that line of code, double check that you made sure that you declared variables, these 3 sets of variables up here, and that you actually assign values to your W, X, Y, and Z pin, which are these pins, these numbers right here. So I'll go ahead and start the simulation, and you'll see that it works. It'll start off with, and it's counting a little bit quickly. So I'm going to fiddle with the delay, but you'll notice it's basically counting up a 4-bit binary sequence starting from 0 all the way up to 15. Right, so then that would be 15. It starts back up at 0, then 1. So it starts at 0, then it goes to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So I'm going to go ahead and extend the delay line to be 1.5 seconds. That way we can clearly see and count up with the counter. Would be 4 in binary. And remember, in our binary sequence, wherever there's a 0, the LED would be off. And whenever there's a 1 in our sequence, it's going to be, the LED will be on. So it'll go all the way up, and then 15, and then it'll stop. And repeat all the way back to 0. Yeah, so your resistors, if they're at 220 ohms and you think your LEDs are a little too bright, you can bump it up, but be careful not to bump it up too much, otherwise you're gonna blow up your LED. If your LED bulbs aren't lining up, make sure you have the right connections, right? So that basically is giving you, it could be multiple things. It could be your wiring or it could be your code. Double check your wiring. Make sure you have the 5-volt pin going up to the positive rail and the ground pin going up to the negative. Make sure that you have your LEDs, the anode, connecting to your pins. The anode is the positive side, and make sure that cathode of the LED is connected to a resistor. I use 220 ohms, and then make sure that you ground it. So take that second terminal and connect it to the negative rail. Make sure your connections are right. Another thing why your LEDs might not be loading up is if you haven't written this part of the code, the pin mode, that's actually telling it to have an output or an input. So make sure that you declare these W, X, Y, and Z pins that you declared up here as variables, but then you actually initialize them to be actual numerical values within your void setup. Make sure that you have those as outputs. Right. Line 27 is just a comment that I have. So it might look a little bit different. That shouldn't be giving you any errors, but in case it is, you can just cut that because the comment is just something that you have for your sake. It doesn't actually affect the functionality of your code. Right, yeah, make sure you have your stuff grounded If you need me to scroll up a little bit, give me 1 second. Yeah, so this error right here, the delay 1000 is wrong in the last curly brace. Make sure you have a semicolon right there, because I believe I sent you the code in the chat before I added that semicolon. Make sure that should fix that part. And to print your values to the serial monitor, I can touch on that in just a little bit. I just want to make sure that everybody has their code working. I'll go ahead and cut and paste this entire code into the chat. And when you're cutting and pasting this, make sure that you replace all the lines of code that TinkerCAD adds in as like a framework and a blueprint. Make sure you delete all of that and then cut and paste this code, right? And if your schematic still isn't working, even after you've deleted everything in the text box and cut and pasted what I've sent you, check your wiring, right? So go ahead and copy that, send it in the chat. Yes, I can send it in the Q&A as well. Or yeah, so this one would be if you don't have a semicolon after the delay function. And then I'll touch on this in just a minute. I cannot copy and paste onto CAD. Right, so I'm going to be sending you the code directly. So you should just be able to highlight it, Control-C, Control-V into the text. Make sure when you're writing your code, you hit code and you go all the way down to text. Don't go to the blocks, just because we wrote our code completely from scratch this time, which I think was a little more streamlined than figuring out what blocks to use. All right, if you have gotten your schematic to work, your code works, then you are more than free to go ahead and leave. Once again, as we kind of touched on before, this entire code that we wrote today from scratch, I'm going to compile that just in like a text file. I'm going to have that sent to the library, who will then send it to all you guys along with the PowerPoint that we also talked about in today's session. So I will go ahead and stop sharing my screen and bring you guys back to the questions in case there are any. Back to our PowerPoint.
All right, Nuhan, I will go ahead and share those slides for those who are still in. And again, like she said, those will be sent out as well to all participants later on.
And I think there was one question that I left to answer, but I'll go ahead and answer that right now. And this question is about how do I get my numbers to print, right? So my zeros, ones, two, my zeros and ones for all my numbers, how do I get that to actually print? So the way you're going to do that is you are going to just have your code, and what you'll do is you can write a code down here after the delay. This is for if you want to print out the actual binary sequence, right? That Y value, X value, W, Z value, all those values. We'll go ahead and print those out. And what we are going to do is we can write serial.println, And remember that serial print goes with that serial begin. So unless you have that serial begin in that void setup, then it's not actually going to be sending data to print. But if you have that in there, it should work just fine. You're going to write serial dot print. Make sure it's serial with an A, not with an E. Be careful about your typos whenever you're typing code. And we can write it to be, let's say we want to have counter equals, and then we'll have the counter. And then we can also have the WXYZ. These are our bit values. We can have that print, and then it's going to print W underscore value, Y underscore value, or excuse me, X, WX, and then comma Y underscore value, and then Z underscore value. And so this line of code will essentially say counter, right? This is just a string, is equal to the number at that given point. Then it's going to print out WXYZ equals, and then those bit values, whether it's 0, 1, or 2. So we'll go ahead and start our simulation. Oh, hold on. What is going on? X was not declared in the scope because it's this, right? Hold on. Why is it not printing? Right, I'm not sure why it's not working. It might be something with just of the syntax with Arduino, but let's go ahead and see if this works. If it's actually, if it can print counter. All right, let's see if this works. Okay, so it's able to print the counter, right? So that's just something that we can adjust. Let's see if we can add it in the same line. Right, ooh, and that's giving me errors. Okay, so here's what I'm going to do. I'm going to write ln right here and take away the ln right there. That's what's going to make it do at the same line, or it should, but it's giving me this error right here.
Hi, Nuha.
Yes.
While you're checking your code, would it be okay for us to pop in and just quickly cover library resources, and then we will hand the screen back to you?
Of course, yes. Let me go ahead and stop sharing for a second.
All right, so let me go ahead and just share my screen, and I'll just go over these resources very quickly. All right, so first we want to thank you all for joining us today. We just want to share a few resources that you can get here at the Plano Public Library. First, we have our STEAM kits. So for hands-on STEAM activities, we offer STEAM kits for all ages. STEAM kits include learning components for science, technology, engineering, arts, and math to support STEAM-based learning. Our teen STEAM kits focus on technology and problem solving. So you can check out STEAM kits like the Teen Kano Computer Kit or the Little Bits Arduino Kit and more. And you can check these out at the Plano Public Library catalog. Next, we do offer 3D printing services at the Davis Library, Harrington Library, and Parr Library. You can use 3D design software programs like TinkerCAD to design your own 3D model. You can submit your design as an STL file on a USB flash drive and let Plano Public Library print your creation. And for more information on how to submit your 3D design, pricing, and 3D printing classes, check out the Plano Public Library website. And you also, with your Plano Public Library card, have access to thousands of courses on LinkedIn Learning. So you can expand your coding knowledge by checking out courses on Arduino, TinkerCAD, C++ programming, and more. So you can access LinkedIn Learning on the Plano Public Library website under Research and Learn. And we would just like to note that that Frisco residents do not have access to this service, unfortunately. All right, but I will hand it back over to you, Nuha.
All right, thank you so much. So I'm to print out the counter. Let me go ahead and share my screen again. And if this doesn't work, I'll go ahead and share this code that I have right now, and then we'll go ahead and send that out to those attendees. But for example, if we want to have serial.println counter, and then serial.print print for the actual value of counter. Let me go ahead and clear that serial monitor because that's from when I last ran it. Missing a semicolon. Let's start that up again. So this essentially writes counter 0 and then counter 1, counter 2. And the reason why that output is a little bit different is just because of the syntax of the serial print line and print. So that's something that you can kind of play around with at home and kind of delve in as far as how the syntax works for serial print. But this is kind of the general idea of how you would get that. And then if you want to actually print out the ones and zeros in that binary number, you tell serial print to print out these specific variables. That's kind of the idea, that if you want to print those out, then that's kind of the line of reasoning. And then you can, or the kind of line of thought that you should have. And then that should work. And you might need to fiddle a little bit with the syntax of the print function within the Arduino command to kind of print out cleanly as you want it to, or whichever way that you want it to.
All right, well, thank you, Nuha, so much. That was great. And thank you, everyone, for joining us today. This back up here. So again, we just want to thank you all for joining us, and we'd like to give a special thank you to our presenters at SWE for this amazing 5-week program series. We really appreciate you being here. And you want to make sure to stay up to date with Plano Public Library by following our Facebook page and checking out our blog at planolibrarylearns.org. There you can find recordings of past programs and other materials about how to take advantage of everything Plano Public Library has to offer. And please complete our program survey, which should pop up following this program. We value your feedback. And again, thanks to you for joining us for STEAM Skills, Coding, and Circuits.